You know that feeling, right? You get a test back, look at a wrong answer and think, oh, I knew that. Why did I write that down? Well, it turns out those mistakes we make, they can tell us a whole lot about how our brains actually learn. So, to really dig into this, we're going to look at something from chemistry, a type of problem called stoichiometry. Now, don't worry about the fancy name, just think of it like a recipe for a chemical reaction. It tells you exactly how much of each ingredient you need to make a certain amount of the final product.
On the surface, it seems super straightforward, doesn't it? You just follow the steps, do the math, and boom, you get the right answer. It's supposed to be as logical and predictable as following a recipe.
But, and this is where it gets really interesting, a major study found that even experienced chemistry teachers were making mistakes on these problems. And the truly weird part, their mistakes were completely inconsistent. They'd get one question right and then totally mess up a very similar one right after. So what in the world is going on here?
Okay, so let's just look at the process. On paper, it's pretty simple. There are 4 basic steps. You balance the equation, you convert your units to moles, you use this thing called the mole ratio, and then you convert back to whatever units the question asks for. Seems easy enough.
But then, you see this. This is a real page of answers from one of the teachers in that study. It's kind of a mess, right? A mix of correct steps and incorrect steps. It's really hard to follow the logic. This is where that clean, simple theory crashes head-on into the messy reality of how our brains actually grapple with problems.
And this wasn't just a one-off. Researchers from the Journal of Chemical Education dove deep. They analyzed a whopping 361 sets of answers from these teachers. They were determined to figure out the hidden patterns behind all these mistakes.
Now, to understand what they found, we first have to talk about the traditional way we think about errors. Let's call it the classic theory.
For a long time, the dominant idea has been something called misconception theory. The thinking goes like this. When we're learning, we build these little theories in our head. Sometimes those theories are just plain wrong, but they make sense to us. So the teacher's job is to find that flawed idea, confront it, and replace it with the correct one.
This image really nails the concept. The mind is like a puzzle, and a mistake, or a misconception, is just a broken piece that doesn't fit. The solution seems obvious, right? Just pull out the broken piece and swap in the correct one. Simple.
But think about it. If this broken puzzle piece theory is right, then you'd expect something very specific: consistency. If you have a single flawed idea in your head, you should make the exact same mistake every single time you face a similar problem.
So when the researchers started crunching the numbers from all those teacher answer sheets, what do you think they found? Well, it wasn't consistency. Not at all. To really get what they discovered, we have to think about knowledge on a spectrum. On one end, you have knowledge that's like a solid, well-built brick wall. Everything is connected and coherent. And on the other end, you have knowledge that's more like a pile of loose bricks, just a bunch of disconnected little pieces. And here's where it gets really cool. The type of mistake you make can actually tell us something about how your knowledge is structured. If you're super consistent with your errors, it's like you have a single faulty brick built right into your wall. But if your mistakes are all over the place, it suggests you're just grabbing random bricks from that loose pile, hoping they'll fit. And this chart, this is the bombshell from the study. What it shows is that for almost every type of mistake, the teachers were incredibly inconsistent. I mean, look at that. For most errors, they only made the mistake on 1 out of 4 problems. That just completely torpedoes the idea that they were holding on to a single, flawed theory.
Okay, so if the whole broken puzzle piece idea doesn't hold up, what's the alternative? We clearly need a better model for what's happening in our heads.
And that brings us to this other idea, often called the knowledge in pieces theory. It suggests that our knowledge isn't one big, solid thing. Instead, it's more like a mental toolkit, filled with lots of smaller, context-dependent ideas. The key here is that the individual tools aren't wrong or broken. The mistake happens when we pull out the wrong tool for the job at hand.
So instead of a puzzle with a broken piece, this model sees the mind more like a network. A mistake isn't a faulty node, it's a weak or misdirected connection between nodes. And that means the goal of teaching completely changes. It's not about replacing ideas, it's about helping students organize them and build stronger, more accurate connections.
When you put the two models side by side like this, the difference is just so clear. The classic theory is almost like performing surgery, trying to cut out a bad idea. But the knowledge in pieces theory, well, it's more like gardening. You're carefully tending to the connections that are already there, helping them grow in the right direction.
Now, this isn't just some abstract academic debate. This shift in thinking has huge, real-world implications for how we should actually teach and learn.
This table really breaks down the practical difference. Let's say a student messes up a problem using proportions. Under the classic theory, you'd assume, well, they just don't understand what a proportion is, and you'd start from scratch, reteaching the whole concept. But with this new model, your thinking shifts. You might think, they probably do know what a proportion is, they just didn't recognize that this was the right situation to use it. So instead of reteaching, you help them spot the clues in the problem that scream, hey, use a proportion here.
This changes, well, pretty much everything. You move away from confronting and replacing knowledge, and you move toward acknowledging and organizing it. You start to see a student's prior knowledge as a resource you can build on, not a barrier you have to tear down. It becomes all about refining how they apply the ideas they already have in their toolkit. So all of this really forces us to come back to a really fundamental question. What even is a mistake anyway?
This quote from the research paper just sums it up perfectly. It says that a learner's knowledge is made of pieces, and even though an idea might be faulty in one situation, it could be super productive in another. That means it should be seen as a resource for learning, not a barrier. Basically, a mistake isn't a sign that you're wrong. It's often a sign you've used a perfectly good idea in the wrong place.
So, I'll leave you with this question. The next time you make a mistake, are you going to see it as a failure that simply needs to be corrected, or will you see it as a clue that needs to be understood? Because thinking about it that way might just change how you look at learning forever.